Hi guys, welcome back to Mathematics for Engineering 3. This is the fourth video on the first order ordinary differential equation. In this video, we are going to talk about a special type of ODEs when m and n. Remember the the coefficient of the dx and dy are linear functions, right? In the previous videos, we look at the ODEs when they are separable, right? And the other one is when m and n are homogeneous of the same order. Do you remember how to solve the ODEs when m and n are homogeneous of the same order? It's in the previous video. If you don't remember, pause here, okay? Stop here and go back to the previous video and watch it first, because you're gonna need it in order to understand what we are going to be talking today, okay? But if you do, great. Okay, so okay guys, as I told you, we're gonna look at the ODEs when m and n are linear functions. So if you look here, this is actually m, right? And this is n, right? We're gonna look at a special class of ODEs when m and n are linear functions. So these are linear functions, no square root, no x squared, no y squared, no x cubed, no exponential, no logarithm, right? They are just linear functions. So this is the form ax plus by plus c, ax plus by plus c. Okay, so we're gonna look how to solve this ODE. As you can see, when they are linear functions, they have constant term here. So you can check if the c's aren't zero. If they are not zero, if c1 and c2 are not zero, they aren't homogeneous of the same order. You can try, looking at that. It's pretty easy to look at. So in this form, sorry, if c's aren't zero, you can't really use homogeneous, the homogeneous case to solve it. So how? So how should we solve it? How should we solve it? We're gonna split this into two cases. The first case is when you can solve this system of linear equation and you have a unique solution. That's the first case. The first case is when you can obtain a unique solution. Unique mean only one. If you can have only one solution, okay, unique solution. So say that that solution is x equals h and y equals k. So that's the first case, is when you can obtain the unique solution. You can obtain the unique solution when a1 b2 is not equal to a2 b1. Okay, it will become clearer in when we do exercises, but I believe that all of you can solve the system of linear equations. We did that in primary school, remember, in Mathayom 3. Sorry, that's secondary school, in Mathayom 3. Okay, anyway, so once the system of linear equation, these two equations, we can solve them and we can get the solution, which is h and k. And if we let x bar be x minus h and y bar be y minus k, we can write this equation in this form. Okay, so the equation becomes ax bar plus by bar dx bar, ax bar plus by bar dy bar. So basically the constant term disappear when you substitute x by x bar. Okay, okay. Why? I'm not gonna talk about that yet. We're gonna look at that in the end. Okay, my style. I love looking at exercises first to let you get familiar with all the exercises and how to solve them, and then we look at the theory later. Okay, because you are soon to be engineers, right? You're not mathematicians. So if I'm teaching mathematicians, I'm gonna teach in different approach. We need to look at definitions, we need to look at theorems, we need to prove the theorems where they are from, and then we start looking at exercises. But for you guys, I think it's a lot easier to just believe me, just believe me, that that this equation can be written as this: when x bar is x minus h and y bar is y minus k, and then we go to solve like problems and problems and exercises, and then we get back to the theorem why this can be written as this, why. But we'll get back to that later. Okay, and once we can write this as this, right? Once we can write this as this, you can see that there's no C anymore, right? There's no C1 and C2 anymore, right? And in that case, this equation becomes an ODE when M and N are homogeneous of order 1. Okay, so it's back to the previous video. It's back to the case when M and N are homogeneous of order 1. So that's why I told you, if you don't remember how to solve ODEs when M and N are of the same order, just pause here. It's not too late, okay? Just pause here. Go back to the previous video, try to understand them, and then you come back here. I'm still here. I'm always here, right? I'm on YouTube. I can't go anywhere. Okay? So I'll be here. So go back and come back here again. Look at this, okay? Okay. So for now, I assume that all of you remember how to solve ODEs with homogeneous coefficients, okay? So some of you might not be able to see that this is actually homogeneous. So I'll look at it closely. So m of x bar y bar is this guy, isn't it? Right? And n of x bar y bar is actually this guy, right? This guy. So if I want to check whether or not m is homogeneous, what I need to do is what? M of tx bar, ty bar, right? And then I'll write it in this way. It would be a1 tx bar plus b1 ty bar. And why? Because, right, I just substitute x bar by tx bar, right? Because we are looking at m of tx bar, right? So instead of using x bar here, I need to use tx bar. So I change this to tx bar, right? We did that in a previous video already, right? And you should know that from high school, right? So I'll pull the t out. So what I have here is a1 x bar plus b1 y bar. Okay, I'll close the. I'll turn off the video. So this is actually t of what? T of m, isn't it? So it means that m is homogeneous of order 1, right? Because it's t to the t to the power of 1. And similarly for n, we get a2 tx bar plus b2 ty bar, which is t a2 x bar plus b2 y bar, which is t of n, isn't it? So it means that n is actually homogeneous of order 1 as well. So m and n are homogeneous of the same order. So we need to go back to the previous section to solve this equation. So let me sum it up. First, when we see equation with linear coefficients, right? The coefficients m and n are linear functions. Then we for the first case we solve for x and y, and let's say if x is h and y is k, we know the solution. If we let x bar be x minus h and y bar be y minus k, we're gonna get this equation. Okay, so this equation is the same as this equation, and this equation is homogeneous. It has homogeneous coefficients of the same order, right? So we solve this equation instead. Make sense? So let's look at some examples. Here, this is linear and this is linear as well, right? There's no x, but so it's actually plus 0x here, right? There's actually x there, but it's 0x, so you don't need to write x, right? So in this case, if you want to compare these with this form, ax1 plus ax plus by plus c, we have that a1 is 0, b1 is 1, and c1 is 9, right? Because if you want to look at this as a1x plus b1y plus c1, so there's no x there, so it means that a1 is 0, and b1 is what? B1 is 1, because y here is actually 1 times y, right? And then c1 is 9. Okay, I'm going pretty slowly, right? So try to go with me, okay? If you don't understand any of these, I understand that it can be confusing sometimes, so just ask me, okay? Just ask me. Not now, right? Because right now I'm recording it. You can't really ask me, but text me. Okay, text me. I'm happy to help. I'm happy to answer any questions. Okay, so for this one, we know that a2 is 2, b2 is 1, and c2 is 1. So first we need to ask whether or not it has a unique solution. Whether or not it has a unique solution. So it's the same as whether or not a1 b2 is not the same as a2 b1. Right? So a1 b2 is what? Is 0 times 1, which is 0, right? And a2 b1 is 2 times b1 is 1, which is 2. So it means that a1 b2 is not the same as a2 b1, which means that there is a unique solution. Okay, so first just check whether or not there's a unique solution. There's a unique solution when a1 b2 is not equal to a2 b1. Make sense? And in that case we'll solve for the solution, right? So the first equation is y plus 9 equals 0. The second equation is 2x plus y plus 1 equals 0. And from this equation, we have that y is actually minus 9, isn't it? Right? and then we substitute y with minus 9. So we have that 2x minus 9 plus 1 is 0, which means that 2x is 8 or x is 4. So right now we can, we obtain the solution of these, linear equations, right? Linear functions. So we have that k is 4 and h is minus 9. So we substitute x bar, we let x bar be x minus h, right? Which is x minus 4. And y bar is y minus k, which is y minus 9. Don't forget, k is minus 9. Oops, sorry, it's the other way around. Sorry. H is the solution of x. So h is 4 and k is minus 9. Sorry, my bad. Okay. So y minus k, but k is minus 9. So it would be y minus 9, which is y plus 9. Yeah? Clear? So if I let this equation be equation star, I can say that star can be written as I'll substitute y by y bar, right? And x with x bar, right? So what I have is y bar, but we don't have c1 and c2 anymore. So it's y bar, x bar plus 2x bar plus y bar plus 1. Oh, no, there's no 1 anymore, right? dy bar equals 0. I'll call this equation double star. Make sense? So we begin with this equation where m and n are linear functions. Okay, m and n are linear functions, and then we know that it has a unique solution. So I find the solution, which is 4 and minus 9. So I let h be 4 and k be minus 9, and I let x bar be x minus h, which is x minus 4, and y bar be y minus k, which is y minus 9, which is y plus 9. And this equation can be written as this, right? It's basically substitute x y by y bar, x by x bar, and we have no constant term anymore, right? So this is what we have here. It's actually for this one, what I wrote here, right? Just follow the step, okay? Just follow the step that I have given. So you're gonna succeed, following the steps. So here you can see that this m and this n are homogeneous of order 1. I'm not gonna show that because we have shown that here already, right? They always become homogeneous function of order 1 because of the fact that these are linear and there are no constant terms anymore. They are not C1 and C2 anymore. So in that case, what would you do when we see ODE with homogeneous coefficients of the same order? Remember? So this goes to the previous video, right? So I tell you that we can look at the number of terms, right? Here and here, right? So let's go a little bit back to the previous video. Sorry. So here we go back here. So if m and n are homogeneous of the same order, we see whether or not, if the number of terms in n is smaller, there's less terms in n, we let y be bx, right? We let y be bx. But if the number of terms in m are smaller, we let x be v what? Vy. Okay? But in our problem, the number of terms here, there's one term, right? And here there are two terms. So I'll let x, but in our case it's x bar, isn't it? We don't have x anymore, right? We have x bar. I let x bar be v y bar. Make sense? I let x bar be v y bar. Okay? Okay. So dx bar is v dy bar plus y bar dv, isn't it? Right? And then we substitute this back into this equation. So what we have is, what is it? Y bar, use some other color. Y bar v dy bar plus y bar dv plus 2 x bar is v y bar, isn't it? Right? And y bar is y bar dy bar equals 0. Okay, makes sense? So what we have is y bar v dy bar plus y bar square dv plus 2 vy bar plus y bar dy bar equals 0. Okay, so basically I just multiply y bar into the parentheses. Okay, and next, we know that it becomes separable somehow, right? So I'll write it in the form that is is separable. So what I have here is y bar squared dv plus 3 vy bar plus y bar dy bar equals 0. Right? I basically put combine this and this, so it turns to be 3 vy bar plus y bar dy bar. Make sense? Does it make sense? Okay, and then I pull y bar out. Oops, sorry. I pull y bar out. 3v plus 1 dy bar equals 0. Okay, so here it becomes 1 divided by 3v plus 1 dv plus 1 divided by y bar squared dy bar equals 0. Right? So first I divide the whole equation by 3v plus 1. So I get it here, and this cancel out, right? And then I divide the whole equation by y bar squared. So this disappeared and 1 cancelled here. So we have, oops, sorry, we have just y bar, not y bar squared. Okay, so now it looks separable. This one is quite hard, isn't it? Because it begins with linear functions. and then we need to find the solution, and then we do the substitution. We get homogeneous, right, of all the one. And after that, we need to, to solve this homogeneous somehow by using this trick that we did in the previous video, and then it becomes separable, right? And then we need to solve it using separable techniques, right? So I'm gonna copy this to the next page as we ran out of space. Okay guys, so we're gonna solve this using the the separable techniques. So basically we're gonna just integrate throughout the equation, right? So this become a constant term, right? So let's look at each each integral. So here is 3v plus 1 dv here. So if you remember in calculus, right, what we need to do is we need to do this, the substitution, 3v plus 1 and d of 3v plus 1. But d of 3v plus 1, okay, I'll note here, d of 3v plus 1 is actually 3 dv, isn't it? Right, it's 3 dv. So, but here we have only dv, right? So we need to somehow put 3 and 3 there, right? So 3 dv would become d of 3v plus 1, and that in that case we have 1 right here. Make sense? This is in integration by substitution. If you don't remember them, go back to calculus 1 or just come and ask me. I'll help you. Okay. So it turns to be 1/3 of log of 3v plus 1, right? And the other one is pretty simple, y bar dy bar, and this one is just log of absolute of y bar. And in that case, we have that is 1/3 of log of 3v plus 1 plus log of y bar equals c, isn't it? Right? And then guys, I've been asked multiple times that when we integrate this function, we should have c1, right? And when we integrate this function, we should have another c, which is c2, and this should be c minus c1 minus c2, right? But in ODE, we just don't care. Why? Because c is a constant. So if what if it is subtracted by c1 or c2, they are it's still a constant, right? It might not be mathematically correct rigorously, but it's still okay to do that in ODE. So basically this c is not the same as this c, okay? But it's still a constant, so we don't really care much. Otherwise, we need to do c1, c2, c3, c4, c5, and it's annoying, okay? And then I multiply the whole equation by 3. So I'll get, what is it? Log 3v plus 1 plus 3 log of y bar equals c. You see? It should be 3c, right? It should be 3c. But I don't care. Why? Because c is a constant. 3c is also a constant, so I don't really care. I'll write c. The same c, right? But keep in mind that this c and this c, they are not actually the same. But as they are constant, so for simplicity, to be convenient, we just keep writing C. It's okay, no problem. Okay, so here is going to be log of absolute of 3v plus 1 times y bar cubed equals C. Make sense? Make sense? Here, 3 of log of y bar is actually log of y bar cubed. Right? You can just push that up here, right? From, logarithm property. Cool? And as I told you before, if you have the log here, you get that it's absolute of 3v plus 1 y bar cubed equals e to the c, right? But e to the c is actually a constant, so I don't care. I still call it c. Make sense? Make sense? I can call it c star. You can call it c star if you want, but I don't want. I don't care. Okay? Okay? And as I told you guys before, that, if you have, things in the absolute, and this equals constant, you can just remove the absolute, right? If you don't know why, go back to the previous video. I already explained why we could remove the absolute. So here we have 3v plus 1 y bar cubed equals c, right? And then we substitute back, right? We need to substitute back to the original variables. So before this, we let x bar be v y bar, right? X bar be v y bar. Okay, I'll just keep it here. X bar be v y bar. So v is actually what? X bar divided by y bar. So what I have here is 3 x bar divided by y bar plus 1 y bar cubed equals c. Make sense? Does it make sense? Okay, and then I multiply the whole equation by y bar, to make it, more beautiful, to make it prettier. So what I have here is y bar to the power of 4 c. Sorry, here it should be you know what, I'm not doing that. Otherwise the c on the right hand side, they won't be c. So how about I do this? This y bar cubed is actually y bar squared times y bar, right? Is that correct? Y bar cubed is actually y bar squared times y bar. So I'll push this y bar into the parentheses. Okay, parentheses. So what I have is 3x bar plus y bar times y bar squared equals c. I think this is easier, isn't it? Right? But guys, we have the solution. This is the solution, but in terms of x bar and y bar. But don't forget, our problem is in terms of x and y. So, we substitute y bar with y minus k and x bar with x minus h, right? So I'll just keep it here. Write it here. That x bar is x minus 4 and y bar is y plus 9, isn't it? Right? So I'll push that back into the solution. So what I have is 3 x minus 4 plus y plus 9 times y plus 9 squared equals c. See? So we get the solution in terms of x and y. So I'll do it just a little bit more here. So what we have is 3x minus 12 plus y plus 9 equals y plus 9 squared, times y plus 9 squared equals c, or 3x plus y minus 3 y plus 9 squared equals c. And that is the solution. Is it hard? I know it can be confusing because it's such a long process, right, to solve the equation. So just to sum it up, okay. First, we look at this problem, this equation. After that, we see whether or not we can find a unique solution by checking this. And I checked it, and I found that there is a unique solution, right? Which is x equals 4, y equals minus 9. And in that case, what I did was that I let x bar be x minus h and y bar be y minus k, and then I just wrote this equation, right? Because I know that this equation can be written as this, right? But this equation is homogeneous of order 1, right? And it has just one term here. So I let x be vy. But right now we know it's x bar and y bar, right? So it's x be vy. So it's the same as in the previous video, right? So dx is this guy. And then we do the substitution. We get this equation. And we know that it's going to be separable, right? And it is, as you can see here, it is now separable. Then if it's separable, we integrate throughout the equality, right? Throughout the equation. And this becomes c. And the integration of this is this. And the integral of this is this. Right? This integral equals this. And then we push it back there, and we get the solution, right, in terms of v and y bar. Don't forget, guys, we need to substitute, right, v with x bar divided by y bar, as we did in the previous video. And after that, we get the solution in terms of x bar and y bar. And that's not done yet, because we need to substitute x bar and y bar by with x minus 4 and y plus 9 respectively. And after doing that, we obtain the solution. It's such a long process, isn't it? But if you keep doing it, couple of times, 4 times, 5 times, you're gonna get familiar with it, because it's the same process. You begin with equation with linear coefficients, and then you write that, you find the solution, you get h and k, and then you get x bar and y bar, you get homogeneous coefficients equation, and then you let x be vy, right? And then it turns to be separable. After that, you solve separable equations, and then you substitute back twice, and you get the solution. Okay, I spent a great amount of time on this question because I want you guys to comprehend the whole process, because you're gonna need to do it, okay, in the exam. Okay, let's continue. Let's look at another example. You have that this is linear function, and this is linear function as well, right? So we have here that is 9x minus 4y plus 4, and here is minus 2x plus y minus 1, right? I wrote it in that way because you have minus here, so you need to multiply the minus into the parentheses. Okay, so we have that a1 is 9, a2 is minus 4, and c1 is 4, and this is b1, that b1, and a2 is minus 2, b2 is 1, and c2 is minus 1. So in this case, we have that a1 b2 is what? Is 9 times minus 2, which is minus 18. And a2b1 is what is it? It's going to be minus 2 times minus 4, which is 8, right? Isn't it? Okay, so we have that a1 b2 isn't the same as a2 b1, which means that there is a unique solution. Okay, if there is a unique solution, first let's try finding the solution. So we have that 9x minus 4y plus 4 equals 0, minus 2x plus y minus 1 equals 0, right? And I'll call this first equation, second equation, and then I multiply the second equation by 4. I'll let 4 times the second equation. So what I have is minus 8x plus 4y minus 4 equals 0, right? And I call this equation third equation. And after that, I use equation 1 plus equation 2. So I have that is x equals 0, isn't it? Why? Because this, right, if you plus 9x and minus 8x is x, minus 4y plus 4y disappeared, 4 and minus 4 disappeared. So we have x equals 0. X equals 0. And similarly, I substitute x in 2. So what I have is minus 4 plus y minus 1 equals 0. And in that case, I have that y is 5. Is it? Oops, sorry. If I substitute x in 2, minus 2 times 0 is actually 0, isn't it? Plus y minus 1 equals 0. It means that y is 1. So now, I have that h is 0 and k is what? 1. Right? So, x bar is x minus h, which is just x. Right? Because h is 0. Okay? And y bar is actually y minus k, which is y minus 1. So I have that the equation star here. Star can be written as what? Just, substitute x with x bar, right? Y with y bar, x with x bar, x with x bar, y with y bar. y width by y bar, and you just get rid of C1 and C2, right? So what we have here is 9x bar minus 4y bar dx bar minus 2x bar minus y bar plus 1 dy bar equals, oops, sorry, there's no plus 1, dy bar equals 0. And this one, I'll call it double star. And this double star equation is homogeneous of order 1, isn't it? Right? So what should we do? We will let x be vy or y be vx, right? Depending on the number of terms. Right? But in this case, it doesn't really matter, right? It doesn't really matter that much. Why? Because both of them have 2 terms, right? They have 2 terms each, so it doesn't really matter. So I'll let y be vx, so it y bar be vx bar. If you want, you can let x be vy bar, as we did in the previous question. Okay, but I want to do it differently, so I let y bar be vx bar. So in that case, we have that dy bar is v dx bar plus x bar dv. Clear? And then what's next? You just do the substitution, right? And we know that it's going to be separable. Okay, so here we have that is 9x bar. I'll use the red. So it's 9x bar minus 4vx bar dx bar. Okay, because y is vx bar, right? Just substitute, right? And then is minus 2x bar minus vx bar. The y bar is actually v dx bar plus x bar dv equals 0. Make sense? Okay, right? I just substitute dv here, sorry, dy bar here, and dy bar here is actually these guys, so I'll put these guys there. Make sense? So I'll need to somehow make it look separable. How? Look here, I just pull x bar out, so I get 9 minus 4v dx bar, right? And in the next one, I get minus x bar 2 minus v, and this is actually what? V dx bar minus x bar 2 minus v x bar dv equals 0. Make sense? Basically, I just multiply this guy in the parentheses. So it's v and this guy, right? And x bar and this guy. Make sense? Okay. And then for the x bar, I have that is x bar 9 minus 4v minus x bar minus 2 plus v. How about I write it like that? Minus 2 minus v. D. Oops. Sorry, I can't do that. I can't really do that. It's gonna be x bar 9 minus 4v minus 2 minus v dx bar. Make sense? I group this guy together, so I get dx bar here. Okay, and here I probably should use a bigger bracket. Make sense? And the other one is actually minus x bar squared 2 minus v dv equals 0. Okay, and then we have that is x bar 9 minus 4v minus 2v plus v squared dx bar minus x bar squared 2 minus v dv equals 0. Right? So it turns to be x bar v squared minus 6v plus 9 dx bar minus x bar squared 2 minus v dv equals 0. Sense? Okay, I'll copy this to the next page, as is, we're running out of space. Oh, sorry, I forgot squared here. Okay, so I'll copy this to the next page. It's quite long. Okay, and right now is getting closer to the separable form. We just need to divide here by x bar squared, so we get 1 over x bar dy bar dx bar minus 2 minus v divided by v squared minus 6v plus 9 dv equals 0. Does it make sense? And then we have that is 1 divided by x bar dx bar plus v minus 2, right? I'll just put the minus sign here inside the parentheses. So down here is v minus 3 squared dv equals 0. And as you can see, is what? Is separable, right? But so to do that, I just integrate throughout the equation. So here I get c, right? And guys, this is easy, isn't it? Right? Oh, I need absolute here. But this guy, it isn't hard, but it's not straightforward. So how to integrate this function? You remember that? We need to use what we call partial fraction again. So v minus 2 divided by v minus 3 squared. We need to split this into a divided by v minus 3 plus b divided by v minus 3 squared. If you can remember, If you can't, go back to the calculus course. Okay, okay, cool. So if I multiply the whole equation by v minus 3 squared, what I have here is v minus 2 equals a v minus 3 plus b, right? Right? I multiply the whole equation by v minus 3 squared, right? So if I let v be 3 at v equals 3, we have that this is 1 equals 0 plus b. So we know that b is just 1. Okay? Okay. Make sense? Sense? So if we know that b is 1, what is the value of a? What should we do? We just need to substitute b by 1, right, in the green equation. So we have that v minus 2 equals a v minus 3 plus 1, right? Right? And then we let v be any number. Let's say let v be, I don't know, 4, can be any number. So it's going to be 2 equals a plus 1, which means that a is 1 as well. Okay? Okay? So if a is 1 as well, it means that we can write v minus 2 v minus 3 squared by 1 divided by v minus 3 plus 1 over v minus 3 squared. Okay. I'm not sure if the other lecturers are, if they do teach these as well, because they are usually assumed, you are, it's actually assumed that you know these things already from calculus, right? But, I want to help you anyway, but in the end, you need to go back to calculus 1 to look at techniques of, integration, right? Because there are so many of them. It is just one of them that I can help you with. But in the exam, you never know what kind of, integrals that you need to, to do. So it's a problem. So you need to be able to integrate, these functions. Okay. So next, what is it? This is going to be just the integration of what? 1 divided by v minus 3 and plus 1 divided by v minus 3 squared dv. So the first one would be just log of v minus 3. Plus the second one is this guy is actually v minus 3 to the minus 2, right? Right? And integrate d of v minus 3. d of v minus 3 is actually dv. It's the same thing. So there's no problem with that, right? You can do substitution, right? But it's the same thing. So we don't really care. So the integration would be what? The integration of this would be v minus 3 minus 1 divided by minus 1, isn't it? Isn't it? So is log of v minus 3 plus minus 1 divided by v minus 3. Okay. So we have that the solution is log of x bar plus log of v minus 3 minus 1 divided by v minus 3 equals c. Okay. And here I have that it's actually log of x bar times v minus 3 minus 1 divided by v minus 3 equals c. Isn't it? Isn't it? And then we do the substitution, right? Before that, we let what? We let where is it? I kind of lost it somewhere. Oh, it's here. We let y bar be v x bar, right? So I just write here y bar be v x bar. Okay, this is my note. So I need to substitute back, right? So I have that is log of x bar y bar divided by x bar minus 3 minus 1 divided by y bar over x bar minus 3 equals 3. Make sense? Make sense? Make sense? Okay. Right? Because we did the substitution. Y bar equals vx bar. So v is actually y bar divided by x bar. So we substitute it back here. Cool. I may need another page because again we ran out of page again. So I'll just do it a little further to get prettier form. Y bar divided by x bar minus 3x bar divided by x bar equals c. Right? So in that case, I have is log of y bar minus 3x bar minus 1 divided by y bar minus 3x bar divided by x bar equals c, which is log of y bar minus 3x bar minus x bar divided by y bar minus 3x bar. Right? You know this, right? If you have 2 divided by 3 divided by 4, it's actually 2. Oops, sorry. If you have 1 divided by 2 divided by 3, it's actually 3 divided by 2. Okay, you can put this up there. Make sense? Equal c. And the last substitution, what we did was we let x bar be x and y bar be y minus 1, right? So what we have here is, because x bar is x and y bar is y minus 1, so we have here is log of y minus 1 minus 3x minus x bar is x, y minus 1 minus 3x equals c. Okay, and that is the solution. How was it? I know one question takes forever, right? It takes ages to solve. I know, because I'm the one solving it right now, right? But you guys just keep practicing. It's nothing, it's nothing difficult. It's not difficult at all. It's just a long process. You just need to follow the same structure, right? From the equation with linear functions, coefficients, right? And then you verify if there exists a unique solution. And if there is, then you find a solution. right? When you find the solution, you get h and k, right? You get the solution, and then you do the substitution. Let x bar be x minus h, y bar be y minus k, and then you get another equation, right? Which is equivalent to the first one. Is equivalent to the first one, right? And the equation that you have right now is, it has homogeneous coefficients, right? Right? And after that, you did another substitution, right? X bar be vy bar, or y bar be vx bar, and then you do substitution. After that, you get the separable equation, right? And then you integrate throughout the equation. Then you get the solution, right? When you get the solution, you need to substitute back twice. One is when we do the homogeneous equation, and the other one is when you substitute it, you know, when you did the substitution of x bar and y bar, right? And then you obtain the solution. That's it. It's not hard. It's a labor work, you know. It's a long process, right? Okay, makes sense. We get to the next topic. Why does it work? Why does it work? Right? Because before that, we begin with, you know, this equation, and then we say that the solution is x equals h and y equals k, and then I just say that this equation is the same as that. Is it really the same? Is it really the same? Okay, I'm gonna prove that. Okay, guys, h and k are solution, right? H and k are solution. So I have that a1h plus b1k plus c1 is 0. It must be 0 because, you know, h and k are the solutions of the equation, right? Or the system of linear equations, right? And a2h plus b2k plus c2 is 0 as well. Is 0 as well. Okay. Okay. So this equation, I'll call it double star. This equation double star is the same as, okay, I'll do substitution. A1 x bar, right? But x bar is what? X bar is x minus h, isn't it? Plus b1 y minus k dx bar, right? Right? But guys, because x bar is x minus h, right? H and k are constants, right? So x bar is x minus h. It means that dx bar is actually dx, right? And similarly, dy bar is dy. Sorry, this is y minus k. Okay, and dy bar is actually dy. Cool? Is that cool? So here I'll just write as dx. And then the other one is what? Is a2 x bar. What is x bar? X bar is again x minus h plus b2 y minus k, and then dy equals 0, right? Because dy bar is actually dy, isn't it? So what we have here is that we have a1 x plus b1 y minus a1 h minus b1 k, right, 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 dx. Here is a to x minus a to h plus b to y minus b to k. Then dy equals 0. Make sense? Make sense? Right? I'm gonna video out. Here we have that is a1x plus b1y. But guys, as we have that, this is 0. It means that C1 is actually minus A1H minus B1K, isn't it? Isn't it? Right? Right? Just move it a little bit to the left hand side. Right? So this guy is actually C1 dx plus a to x b to y, and these guys minus a to h and minus b to k. Similarly here is C2 is minus a to h minus b to k. Right? Right? Alright again. C2 here is minus a to h minus b to k. Okay? So here is just plus C2 dy equals 0. So right now you can see this equation and this equation are exactly the same. They are exactly the same, which means that if you begin with this equation, you get the solution h and k, and you have that this equation is exactly the same as that equation, and that can be proven here, right? You get that this equation 2 double star is the same as equation star. And that's it, and that is why it works. Okay, cool. Okay, in the next subsection, we're gonna look at another case when there's no unique solution, right? When you get a system of linear equations, there can be 3 cases, right? First, there's unique solution. Second, there's no solution at all. And third, there are many infinitely solution, right? There are infinite solution. There are many of them, right? Right? Okay. So in this case is when it doesn't have a unique solution. So how to check that? How to check that is when A1, B2 is A2, B1. Okay. Okay. So in that case, what you need to do is that you need to substitute. You need to do the substitution. Let u be a1x plus b1y. So basically, you let this guy be u. Okay, or you can let this guy be u as well. But I would recommend you to stick with just one of them. Otherwise, you need to remember many things, right? So just let this guy be u. Okay. Okay, and the ODE becomes separable in u and v. Sorry, in u and y. I'll come back later. Why? Okay, the same style, right? We will do the questions first, the problem first, and then we come back later to see why they become separable. Okay, cool. So just to sum it up, if it doesn't have a unique solution, first you just need to to check whether or not it doesn't have a unique solution using that condition. After that, we do the substitution. We let u be a1x plus b1y, and then the ODE becomes separable. Okay, let's look at some examples. Here, as you can see, a1 is 2, b1 is -3, and c1 is 2. I think you are familiar with it, aren't you? Right? So here, a2 is 12, b2 is -18, and c2 is -3. Okay. So a1 b2 is 2 times -18, which is -36, right? And b2 and a2 b1 is 12 times -3, which is -36 as well, which means that a1 b2 equals a2 b1. So it means that there is no unique solution. Okay. Oh, some of you might be wondering like where this condition comes from. It's actually from you just write these two linear functions as a1x plus b1y plus c1, and the other one as a2x plus b2y plus c2, and then you try to to subtract them, and this condition is when you get the unique solution, right? The thing in the denominator is not 0. Okay, you can do that and you'll see it's pretty simple. Okay, so there's no unique solution, so I'll let u be 2x minus 3y. Okay, right? This is what I told you. I'll let u be this guy. Okay, and then it becomes separable in u and y. Okay, so we need to get rid of x, right? It means that we need to get rid of x. Make sense? It becomes separable in u and y. It means that x disappears, right? X disappears. So here we have that the equation becomes u plus 2, and what is the x? Okay, let's write it here. U is here, right? So we have that 2x is u plus 3y, isn't it? So x is u plus 3y divided by 2. It means that dx is 1/2 du plus 3/2 dy. Right? Okay. So just put it here. So here we have that dx is du plus 3 dy divided by 2. And then we have here that is actually 12x minus 18y is actually 6 of u, right? Because u is 2x minus 3y. So 6u is 12x minus 18y. Right? Remember guys, remember, when you substitute this with u, right? This guy here will, they can be written in terms of u as well. Okay? So if you write this as u, this guy, they must be, I don't know, 2u, 3u, 4u, or u divided by 2, or 1/3 of u, stuff like that. But this guy must be able to be written in terms of u as well. Remember that. Okay? If it can't be written in terms of u, something's wrong. Cool? So is minus 3 dy equals 0. So I told you that this equation is separable, right? From here, I told you it's separable. And let's see whether or not it's separable. Okay, let's write it this way. This is what? This is u plus 2 du. Okay, let me multiply the whole equation by 2, okay? So I get u plus 2 du plus 3 dy plus 2 of 6u minus 3 dy equals 0. And in that case, I have that is u plus 2 du plus 3 u plus 2 dy plus 6 2u minus 1 dy equals 0. Right? And then I have is u plus 2 du plus, what is it here? Is 3u plus 6 plus 12u minus 6 dy equals 0. Right? And see guys, when you substitute this with u, and it will be the multiple of u, and then you don't have y anymore. See, you don't have y up here anymore. So if you don't have y up there anymore, it means that it must be separable, right? Because there's only one variable. Make sense? So here is u plus 2 du plus, what is it? 15u dy equals 0. It means that this guy is u plus 2 divided by 15u du plus dy equals 0. Okay? And then I'll just multiply the whole equation by 15. So I get u plus 2 divided by u du plus 15 dy equals 0. And then this is separable, right? So I integrate throughout the equation, so I get c here. Make sense? So next I have that guys, I'll look at this guy first. Easy. Is 15y, isn't it? Right? But the other one, integrate of what? This one is actually integrate of 1 plus 2 divided by u du, which is u plus 2 log of absolute u. Make sense? So the solution is actually u plus 2 log absolute u plus 15y equals c. But u is what? U is, as we have here, u is 2x minus y. So we have that here is 2x minus 3y, sorry, it's 2x minus 3y, not 2x minus y, plus 2 of log of 2x minus 3y plus 15y equals c. Right? Right? And can I write it here? Just we are about to finish. So here is 2x plus 12y, right? Plus 2 log of 2x minus 3y equals c. Right? And if you want, you can divide the whole equation by 2 again. But I'm not doing that, okay? So that is the solution. Make sense? So is it hard? It's okay, isn't it? Right? So just to sum it up, first you have the linear functions, and then you see that you can't really get the unique solution. You can check it by this, right? A1 B2 is not, is equal to A2 B1, and in that case you can't find the unique solution. You let this guy be U. Okay, and when you let this guy be U, you know that this guy is going to be the multiple of U, going to be 6U in this case, and you need to eliminate the x. By doing that, you get this. The x is this, and then you substitute that in there, right? And then you just rearranging the terms, and then you have the separable equation. After that, you just solve the separable equation and you get the solution. Cool? Okay, before we look at the last example here for this video, I'm gonna get back to the theorem. Got here, it says like y, right? Y. Guys, let me ask you something. Let me take you back to secondary school, right? When you were in Mathayom 3. If you get this equation and this equation, can you find the solution? Yes, of course. And does it, is it unique? Yes, it's unique. You actually don't need to do A1, B2, A2, B1. That's silly. You don't need to do that. Silly. Okay? How about this? If I change this to 3, can you find the solution? No, this equation has no solution. Remember that, right? If these are the same number, and this is 3, this is 5, if you look at the graph, it's gonna be 2 linear functions which are parallel, so you can't really find the solution, right? So if these are the same number, you can't find the solution. Or in some cases, you can find a solution. For example, like that, they are the same equation, right? So you can find the solution, but they are, infinite number of solution. Okay, so how about here? 4x plus 6y equal 5. So you can see, you can come from here to here by multiply the whole thing by 2, right? So here 2, it becomes 4. 3, it becomes what? 6. Means that if you can multiply this equation and you get the same coefficient as this, it's back to 4x plus 6 equals what? 6, and 4x plus 6y equals 10, equal 5. So it's back to the case where you don't have the solution, right? This is when you were in secondary school. So in secondary school, we know that for two linear equations, to not to have unique solution, these x and y, they can be derived from this. If you multiply this by 2 and you get this, the solution is not unique. Okay, let's look at another example. If I say is x minus 3y equal 5 and 3x minus 9y equals 1. See? Oops. Sorry. Okay, sorry, there was a glitch in the iPad. So in this case, here you can see, this is, if you multiply this equation by 3, you get this equation, right? You just ignore the constant, you just look at this term, right? In that case, we have that there's no unique solution. Okay? So, when there's no unique solution, if you let this equation, if you let this term be u, it is sure that this term will be ku. When k is a constant, it will be 6u, 3u, some u's, right? Why? Because as I told you, if there is no unique solution, this can be written by multiplying this by some number. Okay? That from Mathayom 6. And in that case, we have only u and constant, So here, m and n, there are no y at all, or there are no x at all, right? Then when you have u here, you can write du, right? So what is du? Du is what? Is a1 dx plus b1 dy, right? So you just put dx in there, so you only have dy. But here there's no y as well. There are no y as well. So in the end, it means that in the coefficient here, there are no y or no x. There is only u. If you look at this example, right, when you do the substitution, you see there's only u. There's no x, no y. And if m and n contain only one variable, it's a must that it is separable, right? It's separable because it's only one variable. Make sense? So before we finish this video, let's look at the last example. Here, you can see they are the same. So if I were you, I wouldn't check, if a1 b2 equals a2 b1. No, I'm not checking that, because it's clear that they are the same thing. They are the same. If they are the same, it means that there's no unique solution. And for this problem, you see, it's 2x minus 3y and 12x minus 18y. I know that if I multiply this by 6, I get that. So if I were you, I wouldn't do this as well. It's waste of time, right? I can't just say that because it's 2x minus 3y and the other one is 12x minus 18y. I know that there is no unique solution. Make sense? So here, I'm gonna let u be 3x minus 2y. So, I know that x is u plus 2y divided by 3. So, dx is du plus 2 dy divided by 3. Okay. So, in that case, I have that the equation turns to be u plus 1 dx, which is du plus 2 dy divided by 3, plus u plus 3 dy equals 0. Sense? And then, see, there are only u, right? There's no x or y. We have only dy and dx, but there are no x and y anymore. See? So it needs to be separable. Okay? So, we just work with it. So I'll multiply the whole equation by 3. So I get 3u plus 9 dy equals 0. So I have u plus 1 du plus 2u plus 2 dy plus 3u plus 9 dy equals 0, which is 1 plus u plus 1 du plus 5 is, did I do anything wrong? Is 2u plus 2u 2u plus 2, isn't it? 2u plus 2, sorry, 2u plus 2, right? I multiply this into the parentheses, right? It will be 2u plus 2 dy. Sorry. So it's 5u plus 11 dy equals 0. So I have that is u plus 1 divided by 5u plus 11 du plus 1, sorry, plus dy equals 0. Make sense? Make sense? Okay. So what is next? What is next? I'll just look at each of them individually. Okay, individually. Oh, well, before doing that, let me multiply the whole equation by 5. So I get 5u plus 5 divided by 5u plus 11 du plus 5 dy equals 0. Why did I do that? You're gonna see in a minute that it turns to be easier when I multiply the whole equation by 5. Why? Let's look at these guys first. Okay, it's separable, so I integrate this and this c. We have done that many times, right? So I'm gonna get speedy here. So integral of 5 dy is actually 5y, isn't it? Right? And the integral of 5u plus 5 divided by 5u plus 11 du is integral of 5u plus can I do this? It's plus 5, isn't it? It's plus 5, isn't it? Can I plus 6 and minus 6? I plus 6 and minus 6. So if I plus 6, it becomes 11. And then I have minus 6 of 5u plus 11 du. Make sense? Make sense? The technique from, integration techniques. So I plus 6 and then minus 6. Right? So it's the same as plus 0. So it doesn't change anything. So if I plus 6, 5 plus 6 is 11. And then I have minus 6 here. Okay? And that is just the integral of 1 du minus the integral of u, 5u plus 11 du. Okay? That is just u, isn't it? Minus 6, I'll pull 6 out for now. And then I multiply by 5. Okay, I won't do that. I'll do this instead. 5u plus 11 d 5u plus 11. But what is d 5u plus 11? It's actually 5 du, right? It's actually 5 du, right? Du plus 11 is actually 5 du. So here we have just du. So we can't just change it to 5 du or du plus d5u plus 11. We can't just do that. So in order to do that, I'll need to multiply this by 5 and 5. right? So the 5du becomes the 5u plus 11. So I have 5 here. Makes sense? Sense? Makes sense. So the solution for this one, oh sorry, the integral here becomes minus 6 divided by 5 log of 5u plus 1. Does it make sense? And then I'm just gonna reduce the size of this. I don't want to get to the new page because I want the information here. So I'm just gonna keep this thing here for now. So what we have now is the solution. So the solution is, what is it? What is it? 5y, right? Here, 5y. Plus u minus 6 divided by 5 log of 5u plus 1 equals 0. Sorry, equals c. Sorry. Okay, but u is what? U is actually 3x minus 2y, right? 3x minus 2y. So we have here, it becomes 3x minus 2y. It becomes 3x plus 3y minus 6 divided by 5 log of 3x. It would be 15x. Okay, I just write this way. 3x minus 2y plus 1 equals c. Okay, and that is the solution. Make sense? I'll just stop here. I won't make it prettier. is pretty enough. Okay. For some of you who don't understand here, it's u here is this guy, right? So 3x is here, and 5y minus 2y, that's 3y here. So this is the solution. Okay guys, that's it. How was it for the equations where the coefficients are linear functions? I know this one is a bit tough, right? It's long, right? It's long and it's quite messy. But what can help you is practicing. So if you keep practicing, it's gonna get better and better. Okay, so have you heard of that? Practice makes perfect, right? So keep practicing. Okay, so just to sum it up, today we did the equations when the m and n are linear functions, right? And we have two cases. The first case is when there is a unique solution, right? There's only one solution, and you can check that by a1 b2 equals a2 b1, right? And if there's a unique solution, find it, right? You get h and k, which are the solutions, right? So if you get x and k, you let x bar be x minus h and y bar be y minus k, and then you do substitution, right? And after doing substitution, you get the equation when m and n are homogeneous function of order 1, right? They are homogeneous functions of order 1. And after that, you let x bar be v y bar, or y bar be v x bar, depending on the number of terms in front of x bar and y bar, right? But in this case, I think they're gonna have the same number of terms, so it doesn't really matter, right? They're gonna have 1 or 2 terms because they are linear functions. Okay, and after that, when you do the substitution, the second substitution, you would get a separable equation. Then you just integrate throughout the equation, right? In that case, you get the solution, and then you do the substitution twice, right? First, when you do the substitution for x bar equal v y bar, right, to solve the homogeneous coefficient equations, and the other one is when you did the substitution x bar equals x minus h and y bar equals y minus k. So after doing substitution twice, you will get the solution. The second case, the other case, is when there's no unique solution, right? It's probably there's no solution, or there are infinite solutions. So in that case, you will let a1x plus b1y. Let that guy be u, right? Be u. And you know that a2x plus b2y, it can be written in terms of u as well. It probably is 3u, 6u, or k of u, some constant times u. So in that case, you know that the variable in front of the x and dy is just u. There's no x, no y anymore, right? Right. And we have the x and dy. Then we change the x to du and dy. After that, this equation becomes separable. And then you integrate, right, throughout the equation, and you get the solution. And then you do the substitution, right? You substitute u with the a1x plus b2y, which is the one that you did before that. Just substitute back, okay? And then you get the solution. I know it's a long process, but it's not hard, right? It's the same structure, right? You just follow step 1, 2, 3, 4, 5, and then you get the solution, right? So what I'm trying to do, because you are soon to be engineers, right? I'm trying to get you to teach you in terms of having steps, right? So that if you follow these steps, you're gonna get solutions. Cool. So in the next video, we're gonna look at another type of ODE. I know there are many of them, and there are even more in the next weeks, the coming weeks. But don't blame me, okay? I'm not the one who decided the course, right? I'm teaching what I was told to teach, okay? So but I'm trying my best, okay, to make it understandable and hopefully enjoyable, okay? So in the next video, we're gonna look at equations which are called exact equations, okay? So we're gonna study what exact equations are and how to solve them, okay? And we're gonna be able to solve even more problems, even more ODE equations, okay? So see you in the next video. Bye bye. Take care.